You just want to do a quick one here. One problem. This is kind of a game that you're going to have to play. You got a couple of them in your homework. I'm going to do one that's very similar to your first journey into this type of game. And then your second one, you figure that shit out yourself. Here we are. Find the exact value of the 5 remaining trigonometric functions of theta that satisfy cosine of theta is equal to -8/10. Just by speaking it as -8/10, I've already helped myself out tremendously. Instead of calling it -0.8, which doesn't tell a story, 8/10 allows us to make a triangle, because then it gives us some sort of ratio. I know we all like decimals because they go into calculators oh so nice, but I'm continually asking for exact values. There will be written components to tests, so you're going to have to show work as well. So let's get into it. And we're going to move away from this where I see, yuck, that's gross. Cosine of theta is equal to -8/10. What are you going to do? Make a triangle and go like this? Oops, I needed one other thing in here. I didn't have the whole question. In quad 3. There we go. Now we can do it. So what are you going to do? Make your adjacent -0.8. You're going to make this 1, 1. You're going to use a bunch of decimals. How are you going to get this exact answer? You're just going to punch it on in, make sure that shit works out all nice and stuff. You got a cool calculator. And this one actually works out super clean. This is actually very, very mellow. But man, I could throw something on your test and be like, hey, go find the exact answers of cosine of theta equaling -0.77. Now, good luck with that shit. Plugging that into a calculator and going and getting me the exact answer. So this game, learn. All right, making it too long. Let's move. So this is the same thing as -8/10, which reduces down to -4/5. Oh shit. We have the adjacent. And the hypotenuse, well, kind of. Is the adjacent 8 or is the adjacent 4? That only represents a ratio. It's just a ratio. It's like a scaled down model car. So let's just write down the last of the information. Let's rewrite this. Cosine of theta is equal to -4/5 with theta in quad 3. There's our thing. We got to go get the rest of the trig functions. Yeah. Just do this. Oops. Just draw a line in the third quadrant. Not to scale. And then I'm going to just drop a little perpendicular down and make a right triangle. It's telling us that, well, I want to make sure that this negative's right out here. Right out here in the front. Because it doesn't matter where the frickin' negative is. It could be up top, down below. Even if we're sitting like this. The hypotenuse isn't freaking negative. It's never negative. That's the same thing as -4/5. That's the same thing as the negative being up top. So do not think that just because the negative is sitting on one of the parts of the denominator, that the denominator is negative and the numerator is positive. That's nonsense. A negative is a negative is a negative, and that's up to you. That's one of my tricks I use. I love to throw the negative in a fraction, and I put it on the denominator. I'll put it on the hypotenuse, leaving it for you to understand that the negative doesn't matter where the frick it is. Yeah, buddy. Know the tricks. So now we created. Okay. Theta actually comes all the way around to here. But we're not to reference angles yet. But we're going to think of it as we look at it from here. We're going to use alpha a lot, or theta primes, which your book uses, but whatever. Moving on. So we have our adjacent, -4. So let's write it in. Hey, and that makes sense. Isn't that in the negative x direction? Sweet. And then our hypotenuse is 5. Now we just need to go get our opposite side. So I'm going to call it b. Now the hypotenuse is always positive. Hypotenuse is always positive. Did I ever mention the hypotenuse is always positive? I think I have. Okay. So hopefully you already know what b is. Maybe a 3, 4, 5 triangle? Huh? I've used it quite a bit. Make sure you know that. Don't do extra work when you can do less work. So let's take our a squared plus our b squared, and we'll set that thing equal to c squared. So we have 16 plus b squared is equal to 25, and no shit, b squared is equal to 9. And now we hit it with a square root. But we must remember our plus or minus. So we're like, all right, so this is either equal to positive 3 or negative 3. It's up to us to go and take a look. It's not equal to both. It's not. It's equal to one or the other, and it depends upon the context of the problem. Since b is going down into the negative y direction, isn't that the negative y? B must be negative. That's why I stress that plus or minus so much, is the fact that we get to here and we have to make a decision on that plus or minus. We're like, is it positive or negative? And we find out, since it's in the third quadrant, that's where both your opposite and your adjacent are negative. Hence, b is equal to negative 3. And we just run through and solve it. Holy shit, there you go. It's a 3, 4, 5 triangle, except it's a negative 3, negative 4, negative 3, negative 4, positive 5 triangle. So we go to solve, and we're like, well, sine of theta, not this thing. We'll talk about that in a little while. That'll be the next one. We're going to go into a big old talk on reference angles and worksheets and shit like that. So sine of theta is going to be our opposite, negative 3 over 5. Tangent of theta is going to be our, opposite, negative 3 over negative 4. Negative 3 over negative 4, I think that's 3/4. I'm pretty sure that's 3/4. It's positive. And we are down in the third quadrant, AST, saying the only tangent should be positive out of those three. And I love this trick. That's one of my favorite tricks, is to give you a problem like this and be like, hey, go solve it. Tangent of theta equals a positive number in the third quadrant. Now go find the rest of the trigonometric functions. And I'd say, well, more than half of the class will just be like, nah, I don't care about sines. Sines are a big deal in trigonometry. It's not like a little slap in the hand like in algebra. Remember, you just sine error, it's -1. It's no big deal. Not trig. Not trig. It shows you don't know what you're talking about. We got to be careful with that. Let's finish the problem. Cosecant of theta will just equal negative 5/3. I'm going to put the negative up on the 5 just to make my point. Secant of theta is equal to, flip over cosine, negative 5/4. And cotangent of theta, of course, is just going to be tangent flipped over 4/3. There are our 5 remaining trigonometric functions if cosine of theta is equal to negative 4/5 and theta is in quad 3. There's exact values. Please make sure you know how to play this game this way, and make your triangles in a quadrant so you can tell where things are positive or negative and you don't commit sine error. Sine error is a killer. All right. That can be the difference between an A and a B, or passing or repeating. Let's get it. Next video, we're going to go on a long string of learning how to solve for any trigonometric value. Anything. So there's going to be some worksheets involved. We've got to build our knowledge, starting with the idea of a reference angle. So the next one will be a reference angle. We'll get you a lot of, we'll get you a worksheet as to how we're going to solve stuff. See you in the next.